Hello, and today's Arithmetic Sequences Day 2 learning target is I can write a function to model arithmetic sequences. Again, to remind ourselves, arithmetic sequences are sequences that add by the same number every time. Arithmetic sequences can be modeled by f of x equals mx plus b. F of x is commonly written as y, so y equals mx plus b, but f of x is just a different function notation, and here in arithmetic sequences it is used quite a bit. M represents the common difference, so what that sequence is either going up or going down by. Again, M represents the common difference. B is known as the zero term. So if we were actually graphing an equation here in y equals mx plus b or f of x equals mx plus b form, that would be the y-intercept. Here though, it's known, and that's probably where you've seen that before, but here it's known as the zero term. So yeah, in our last lesson when we were solving for the zero term working backwards, that's what we'll find here, the zero term again. So let's take a look at a few examples. Given the following arithmetic sequences, let's write an equation to model the following numbers. So this first example, 5, 8, 11, 14, 17. Every time it's going up by 3. So I'm going to say m equals 3 for the common difference. Instead of cd equals 3 like in the past, m equals 3. And now let's find our y-intercept, or zero term I should say. So here is my first term, second term, third, fourth, fifth. I want to find my zero term. So if I work backwards, what plus 3 equals 5? Well, if it doesn't jump out at you that that's 2, we could always say what's 5 minus 3 and work the other way. So here, b, or my y-intercept, or zero term, and I keep saying y-intercept because that's usually how we commonly see b represented as. Here it's the zero term, that's 2. So now when I put it all together, I have f of x equals, again, mx, so 3x plus 2. Now, if I were to put in any number, I would solve, or anything for x, I could solve for any value I wanted. Like here, our first term is 5, right? So if I plugged in 1 for x, meaning the first term of the sequence, I should get an outcome of 5. 3 times 1 is 3, plus 2 does equal 5. We see that there in our function. So we know that this equation will model this function. Let's try the next one. 20, 16, 14, 12. In between each term, we are subtracting, or actually, this first number should be 18. Typo there. So here, we are subtracting 2 each time, so m equals negative 2. If I work backwards and find my zero term, what minus 2 is 18? Well, that's 20. So b equals 20. So with my entire equation, I now have f of x equals m, which was negative 2, 2x plus 20. That would be the arithmetic sequence for that set of numbers. Now with this third example, what's happening between each term is we are adding 5. So that's the common difference. And if I want to find the zero term now, I'll work backwards. And what plus 5 is negative 26? Well, if we didn't know that, we could say what's negative 26 minus 5, and that would be negative 31. So my arithmetic sequence would be f of x equals my common difference of 5x, and then my zero term minus 31. And that would be the arithmetic sequence for those numbers in that third set. We can also use the equation to determine any given term in an arithmetic sequence. So now we'll write a function to model the arithmetic sequence and then determine the given term number. So let's take a look here at this example. 17, negative 17, negative 22, negative 27. That common difference is subtracting 5. And if we work backwards to find the zero term, what minus 5 is negative 17? Well, we could also reverse that order and say what's negative 17 plus 5 to give us that zero term, and that's negative 12. So my function will be f of x equals negative 5x minus 12. That's my function, or that's my arithmetic sequence written in function notation. And now let's find the 50th term. So what this means is wherever I see x, I'm going to plug in 50. Then I'll solve the right side of the equation. So here I'm going to, put in 50 for x here. So f of 50 means we are finding the 50th term of this sequence. And now what we will solve is negative 5 times 50 minus 12, and that will give us our 50th term in the sequence. So in my calculator, I'll type in negative 5 times 50 minus 12. If I didn't know right away that would have been negative 262, I can always use my calculator to help solve. So my answer, f of 50, equals negative 262. So you're telling your readers, the 50th term here is negative 262. And again, we could find any number we wanted, or any number of the sequence. All right, let's look at the next example here. Okay, so between 3, 9, and 15, our common difference is 6. If I find the zero term, what plus 6 is 3? That's negative 3, so negative 3 is my zero term. And I'll write my function, f of x equals 6x minus 3. And now if I want to find the 95th term, f of 95 equals 6 times 95 minus 3, and 6 times 95 minus 3 is 567. So I can tell my readers the 95th term is 567. And that would be my answer for this second example. All right, let's look at this last example here. Between negative 4, 8, and 20, we are adding 12 each time, so my common difference is 12. My zero term, so what plus 12 gives me negative 4? That's negative 16. So my function is f of x equals 12x minus 16. And then now I need to find the 500th term. So I will say f of 500 equals 12 times 500 minus 16. So 12 times 500 minus 16 is 5,984. So f of 500 equals 5,984. Thanks for listening. Have a great day. Bye-bye.